What's up, people? Welcome to today's session. How are you guys doing? I hope every one of you guys are doing good, taking good care of yourselves, staying safe, and more importantly, preparing for your term one examinations. Because, guys, there's a very limited amount of time. I hope that you guys are, using your time wisely so that you don't have regrets later on in your life, right? So, anyways, welcome to today's session. Because today, guys, we are going to study about something super duper interesting. So once again, welcome and subscribe to the channel, because otherwise this guy is not going to stop laughing at you. Subscribe and also hit the like button, because again, otherwise 5 years of bad luck. Getting it? Not 5 years. Let's make it 10 years. 10 years of bad luck. All right. Hit that like button and subscribe to the channel and share the video as well. All right. Anyways, welcome to today's session, guys. My name is Anoop and we are going to talk about something very interesting today. What are we going to talk about in today's session? We are going to talk about a poem that you probably studied in your 11th standard. In your first standard, not first standard, LKG, UKG probably. This is the poem. Twinkle, twinkle, a little star, how I wonder what you are. Up above the world so high, like a diamond in the sky. Now, what we're going to understand in today's session is, why is it called as Twinkle, Twinkle, Little Star? Why do stars twinkle? What is the reason that stars twinkle? Why, when there is a fire around you, the air above that fire looks like it's flickering? Why is it that you are able to see the sun 2 minutes after sunset and 2 minutes before sunrise? All of this is what we're going to discuss in today's session. Once again, I would like to welcome you all to today's session of Human Eye and Colourful World, session number 3, where we are going to it's not rainbow formation, sorry. It's actually a different slide altogether. But yes, we are going to be talking about your atmospheric refraction. What exactly is atmospheric refraction? And as I started off with, why is it called as Twinkle, Twinkle, Little Star? All right, let's get started. See, guys, here's the thing. When you talk about our atmosphere, our atmosphere is layers and layers of air particles, right? There are so many different layers that you have. It's like so many different layers until the exosphere, beyond which you have your space. Now, when light is entering from one medium to another, like for example, when light is entering from space into our Earth's atmosphere, there is a change in density that is happening. Obviously, vacuum has basically no particles. As soon as the light enters into Earth's atmosphere, it has a certain obstruction given to it. So the density of the air is much more greater. So what will happen is that it will undergo some refraction. And as that light ray enters deeper and deeper into the Earth's atmosphere, by the time it reaches the Earth's surface, it would have undergone several such refractions. Why? Because every single layer of our Earth's atmosphere will have different densities, and more importantly, are something which affects this ray of light. So because of these different layers of air there are, what happens is that ray of light will undergo several refraction as it goes into it. Now, one general rule of thumb you have to understand is this, guys. As we go towards the Earth's surface, the density of the air is increasing. Why is it increasing? Because of Earth's gravity. Earth's gravity will pull all those air particles closer to the Earth's surface, and there are only few air particles that are there on the top. Another way to understand this, why do mountaineers carry oxygen cylinders? Because the density of air is much more lesser. At that altitude, they don't have much oxygen because the density of air is less. So as you go towards the Earth's surface, density of air is increasing. As the density increases, we know that refractive index also increases. So that means that every single time, if a ray of light is coming from the star, let's say, what's happening is that if I draw this as the normal, this ray of light is bending towards the normal. Again, to this surface, again, if I were to draw a normal, it is going to bend towards the normal. Several times it is going to bend. And several times it's going to bend towards the normal. And finally, reach somewhere over here. What is happening here is that the ray of light is undergoing refraction several number of times, because the density of the air is changing constantly. This is what is called as atmospheric refraction. the bending of light or the deviation of light as it passes through the atmosphere because of different densities in air or in the atmosphere. What's happening is that it is undergoing refraction multiple number of times, which is what is called as atmospheric refraction. Simple. Now, why do you need to study this, right? What is the application of it? Is it just for your exams, or do you think that atmospheric refraction also has applications in our day-to-day life? Let me know in the comment section. What do you think? Is it just that CBSE has put it in your, in your syllabus just to make your lives a little bit more harder so that they can have more questions to ask? Or do you think that these things are there in your day-to-day life as well? If you were to ask me, I would say definitely, guys, this is something that you see every single day. Twinkling of stars. Why do stars twinkle? Because of atmospheric refraction. Here's what happens. Imagine that you're standing here. Let's say this is Abhishek sir with spikes and all that. KR Abhishek sir. Yes. This is how I would draw Abhishek sir. He has one goatee. Wait, let me use a different color. He has one tiny little goatee. Thank God at least that is there. Alright. Abhishek sir sees his low. That's all. This is ice, by the way. Ice. Okay. Mouth. Oh wait, one eye got vanished. Wait. Yes. Abhishek sir. Wait. We should put Vedantu t-shirt also. Vedantu t-shirt. Yes. I've never seen him in any other t-shirt in a long time now. So yes. So Abhishek sir with his spike hair is standing on the earth's surface now. Now what is happening is that, let's say there's a star which is very, very far away. Now this ray of light, the light that is coming from the star is undergoing atmospheric refraction before it reaches your eye. Let's say that there are 3 rays of light coming in. There are 3 rays of light that is coming in. Let me use a different color. There are 3 rays of light that is coming in and falling into Abhishek sir's eyes. 3 rays of light. Again, I'm just roughly showing the diagram. Guys, the 3 rays of light coming and falling into Abhishek sir's eyes. Now the thing is this, guys. Atmospheric refraction, or our atmosphere, is never constant. It's like your mood. Sometimes it's happy, sometimes it's sad, sometimes it wants to go and play, sometimes it wants to study, sometimes it just wants to sit and think about stuff, right? Yeah, you know what I mean by stuff, no? Special person. Now, think carefully. Here's what happens. Because atmospheric conditions are constantly changing. Now, I'm pretty sure you've all faced this. Know that you wake up in the morning, it's a sunny day, you decide, okay, today I'm going to wear a t-shirt, and then suddenly it's raining. You wish you had an umbrella. You've had all those experiences. Why? Because our atmosphere is constantly changing. It's an ever-changing, quantity. It keeps on changing every single time. And every time those changes, the refractive index also changes. So here's what happens. Sometimes 3 rays of light are reaching Abhishek's eyes. But sometimes what's happening is that because of this atmospheric refraction, only 2 rays might reach his eyes, or only 1 ray might reach his eyes. Because again, what's happening is that the ray of light is basically bending at a different angle because of the atmospheric refraction. So it might fall somewhere over here. Because of this, what happens is that when all 3 rays in this case, when all 3 rays of light are reaching Abhishek's eyes, he would be able to see the star as a bright object. And when only 1 or 2 rays reach his eyes, what happens is that he would see it as a dull, a little bit more less intensified star. This is what is called a twinkling of star, guys. What you're seeing is sometimes the intensity of light is more because more rays of light are reaching you. And sometimes there is less rays of light reaching you. The intensity is a little bit more lesser. The brightness is a little bit more lesser, giving you the impression that stars are twinkling. But are they actually twinkling? No, they're not. It's like our sun. Does our sun twinkle? And our sun is also a star. So if our sun is not twinkling, why should they? Right? No discrimination. So what happens is because of this. Because there's sometimes more light reaching our eyes, and sometimes less light reaching our eyes. Okay. Now let me tell you one more thing, guys. All that stars that you see, our sun. What if I tell you that none of those things that you see are in that exact same position? Would you believe me? Let me know. Let me know in the comment section. Would you believe me if I tell you that our stars, our sun, is not in the position that we are seeing? It's actually a little bit more raised up. Let me tell you why. Again, because of atmospheric refraction. What happens is that the light that is coming from the sun, or the star, sorry, or the sun, whatever it is, whatever celestial object it is, it undergoes atmospheric refraction and finally reaches our eyes. Now, your eyes is a very curious part. It wants to know where the light is coming from, because your eyes is something which is like, your eyes are like Sherlock Holmes. Even if it doesn't find the answer, it still wants to know where it is. I don't know if that even makes sense, but nonetheless, I'm going to go with it. Listen carefully. Forget the analogies. Listen to this topic, by the way. What happens is this, guys. Atmospheric refraction happens. When Abhishek sir's eyes, spike hairs, yes, okay, you get the point, eh? You get the point. Yes, when Abhishek sir's, or when light falls into Abhishek's eyes, he wants to figure out where the light is coming from. So what does he do? He will trace back the source of this light. He'll try to figure out where the light is coming from. And what you see is that you're seeing an apparent position of the star. You're not seeing the actual star. What you're seeing is the apparent position of the star. So this is why, guys, whatever stars you see are actually a little bit more higher than their actual position, because what you're seeing is the apparent position and not the actual star. But if a star is right above you, like for example the pole star, which is directly above the geometric north pole, in those cases there is no refraction happening, because the ray of light is entering at 90 degrees when it's incidentally at 0 degrees to the with respect to the incident ray, or with respect to the normal, it is incidenting at 0 degrees, so it will pass through undeviated and reach your eye. So here there'll be no such height difference. But when your light is coming at a certain angle, which is happening in most of the cases, what happens is that you're actually seeing the apparent position of the star or the apparent position of the sun and not the actual position of the star. All right. So this is another concept because of what? Atmospheric refraction. And don't you think that this has a real life application? Absolutely yes. The next one I'm going to talk about, again related to atmospheric refraction, is delayed sunset and advanced sunrise. What if I tell you the sun, the star that you see, the sun, the star that you see every single day, the sun, actually raises up or actually, sets in 2 minutes before its actual sunrise, and 2 minutes you're able to see the star or the sun after the sunset as well. Why does that happen? Again, because of atmospheric refraction. Let's say Abhishek sir is standing over here now. Now, look at this carefully. The sun right now, we have the horizon. Horizon is nothing but the region that your eyes can see, beyond which you can't. So this is your horizon right now, and the sun is below the horizon. The light that is coming from the sun is undergoing atmospheric refraction. Again, it's undergoing atmospheric refraction. And when it undergoes atmospheric refraction, what happens is that when your eyes are trying to trace back the source of light, it appears as though the sun is over here. But is that the actual position of the sun? No, it's not. But you're seeing it as if the sun is above the horizon. So you're able to see the sun 2 minutes before the sunrise and 2 minutes after sunset as well. So this is the apparent position of the sun and this is the actual position of the sun. But for your eyes, it looks as though the sun is present there. Again, this is the same for sunset also. This is for sunrise. For sunset also, it's the same exact thing. That is, even after the sun is set, because of atmospheric refraction, you're able to see the sun 2 minutes after sunset as well. And all of these concepts, guys, because all these different phenomena can be explained with one particular concept, and that is atmospheric refraction. I hope you enjoyed the session so far. Hit that like button if you did, because I'm going to ask you some questions based on what we just learned. But before that, guys, do you need more help in your exam preparation? Do you feel like you could have done a lot better in the sample papers or the questions that you've attempted so far? Do you feel like you could have done a lot better if you had maybe a little bit extra help? Maybe if you had someone to ask your doubts to, maybe you feel like you could have done a lot better. I'm sure a lot of you guys have that feeling right now, because every one of us want to do better. We know that we can do better. Every day our parents tell you guys that your parents tell you that you can do much better. Your friends would tell you that you can do much better. Good friends. Your friends like me would my friends and all would be pulling me down. Just kidding. Just kidding. All right. This is just a lame joke. Don't take it seriously. All my friends watching this, I am sorry. But yes, what I'm trying to say is this, guys. whatever your problem is, be it doubt solving, you need someone to solve your doubts. Now, when you're solving doubts, also there's a problem. The biggest problem that you guys are facing at this age because of puberty is what would other people think, right? You think 10 times before you ask a doubt. You think about whether my sentence is correct before you ask a doubt. Why? Because you're worried about being made fun of. All of that, guys, there's a solution for that. And that is Vedantu. Vedantu's classes are all live. You can check out all of the live sessions. Once the session is done, you will get it in my sessions, the past sessions. You can check out all of the recordings of every single session, no matter how big, no matter how small the session is. Let's say I want to see what I learned in the previous session. All you have to do is, guys, click on Get Notes. The entire PDF, the best content that you can find out there, the entire PDF is going to be downloaded. So this makes your life a lot more easier. If you want to go back and refer to a certain derivation, maybe you want to go through a certain definition and you want to write it down, it works perfectly well. Let's say you want to watch the replay. Click on the replay button and watch the entire session. Now, while you're watching the replay, let's say you feel like having a little fun. You want to attempt the questions as well. That is also an option. Imagine that while watching the replay also you can attempt the questions. So this is one of the sessions that happened yesterday. So you can check out all of the sessions. This is how it's going to be. You have the fastest fingers list. You will have something called as the leaderboards. You can check out how the questions are going to be. And these questions are going to help you in your board preparations as well. So if you guys are looking for serious preparations, and you want to have some fun along with your preparation, because it's important to have fun while you're studying while you're understanding the concept. It's important to have fun. So yes, you guys can check this out for sure, guys. This is definitely an absolutely wonderful option for you guys to help make your studies more interesting and more fun. Let's say I want to try out the alternate replay. That is, I want to take the quizzes while watching the replay. That is also an option. Let me just reduce the volume so you can see this is how it's going to be. You guys can take the quizzes while watching the replay also. Let me just go to the quiz part. You can see that over here. So you can see that while you're watching the replay also, you guys can actually take part in the quizzes and check out the leaderboards as well. So yes, guys, again, apart from all of these also, you have tons and tons of micro courses as well. So if you go to my courses, and this is free for all long-term students, you can check out the entire micro course detail, whatever, let's say you are finding light hard, you will have micro course for light chapter. You can join that chapter for free of cost and learn that chapter in a very, very detailed manner. Lots and lots of opportunities. And if you just look at this, let me just show you one more interesting feature. So this is yesterday's session again. If you just go to the number of doubts asked with the master teacher, with me, there were two other teachers as well. Both of them highly qualified. They are all, MTechs, who have done their MTech, that is Master of Technology, BTech, Bachelor of Technology. They have had their share of teaching. And those kind of teachers would be there to solve your doubts. Now, if you just look at this for a second here, 157 doubts were asked. And out of 157 doubts that were asked, all that 157 doubts were resolved as well. You can check that out here. I don't know what happened over there. How you can check it out. 157 doubts were asked, all 157 doubts were resolved as well. And this is how it's going to be, guys. So all of your doubts are solved inside the session itself. And outside the session, if you want to get your doubts solved, you have the Vedantu Doubt app. Just download the Vedantu Doubt app. Get your doubts solved whenever you want, wherever you want. You have more than 250 doubt experts waiting to solve your doubts. So yes, people, the entire solution for all your problems. So if you want to enroll into the course, guys, let me just tell you, this is one of the videos that happened yesterday regarding the study plan. I think it was day before yesterday, sorry, because it's going to be coming out on Sunday, right? So yes, you can check it out over here. So what you have to do is, guys, go to the description, click on show more, and click on CBSE crash course, the first term crash course. Now this is only for people who wants to be with us for the first term alone. You want to prepare for the first term alone with us because the time is very limited. You want a complete revision. You want to go through the syllabus one more time. Then yes, revision, syllabus, you want some test series, everything is available. So just click on this link and it'll directly direct you towards the Vedantu's website. Now here you can check out everything. You can see what are the kind of teachers who's going to be teaching you. You can see every single thing, people. Now, yes, the price of this is 6,300 rupees, which might seem like a lot of money. But think about it for 1 second, guys. Think about it for 1 second. All 6 subjects: physics, chemistry, bio, math, English, social science. For the next 3 months, until your term 1 examinations are done, for the next 3 months, everyday sessions with revision, with notes, with tests, with everything that you need to prepare for your board exams for a very, very nominal cost. 6,300 rupees, and that is after discount. The base price is around 7,000 rupees, but it's coming down to 6,000. In fact, even if you go for the classic version, Vedantu classic version also, even in that also, the price is going to be 6,300. And the best part is, for Vedantu classic, you can even download the app and get your doubts solved as well for the same price. Same price. 24/7 doubt solving facility, live sessions. Whenever you want, you can watch the replay, get the notes whenever you want, everything that you need. So what are you waiting for? Right? So the option is up to you guys. See, it's just a path. Vedantu is a path to help you achieve that goal. Now it's not the only path, but yes, this is one of the best paths there is, where everything is laid out. We have the best of the best teachers to help you succeed in your goals. Right, guys? So with that said, let's get into the quiz questions right now. Let's get into the quiz questions. I hope you guys have gone through that. The link is right there, people. This is the Term 1 crash course. If you guys want to do both Term 1 and Term 2, that is also right there. The link is right there for that as well. So if you just go to crash course Term 1 and Term 2, the entire crash course would be, that is the entire syllabus with revision would be taught to you without any without any prejudice or delay. Everything would be completely done. All right. So anyways, let's solve some quiz questions right now. Yeah, it's kind of hot in Bangalore and I'm wearing a sweater. That is why I'm sweating. For all those who are wondering. All right, here's the first question. We can see the sun before the actual sunrise about what? 2 hours, 2 minutes, 20 minutes, or 0.2 minutes. When are you able to see the actual sun, or when are you able to see the sun before the actual sunrise? Is it 2 hours, 2 minutes, 20 minutes, or 0.2 minutes? I don't know what happens there. All right. It's kind of hot. All right, I'll give you guys 10 seconds. Think about it for a second and then answer, guys. Think about it for a second and then answer. In the meantime, people, make sure you put down the answers in the comment section as well as in the chat box. Make sure that you guys are giving your 100%. The answer to this question in 5, 4, 3, 2, 1 is 2 minutes. 2 minutes is what is the answer, guys, because you're able to see the sun 2 minutes before the actual sunrise and 2 minutes after the actual sunset as well. Next one. As light from a far-off star comes down towards the earth, it bends away from the normal. It bends towards the normal. It does not bend at all. It gets reflected back. What happens as light enters from this light coming from the star enters into the Earth's atmosphere as it comes towards the earth? Is it going to bend towards the normal? Is it going to bend away from the normal? Is it going to not bend at all? Or it is going to get reflected back? I'll give you 10 seconds to think about it and give the answer. But yeah, if you need more time, pause the video. Because the premiered session, pause the video now. You have an option. Yes, use that Sherlocky brains now. All right. I'll give you the answer in 5, 4, 3, 2, 1. I'll give you a hint, guys. As you go towards the Earth's surface, the density of air is increasing. So your refractive index is constantly increasing. If your refractive index is increasing, will it bend towards the normal or away from the normal? It will bend towards the normal, because every single layer it passes through, the density of the next layer is much more greater than the first one, the one before. So it's entering from a rare medium to dense medium. So when light is entering from a rare to dense medium, it is going to bend towards the normal. No? So the answer would be option B. Next one. Refractive index of light by the Earth's atmosphere due to variation in air density is called as what? Atmospheric reflection, atmospheric dispersion, atmospheric scattering, or atmospheric refraction. My God. Is this even a question for 10th standard students? If you get this wrong, by the way, all I can say is this: SSPS. The full form of this, you will know it in the live sessions. So subscribe to the channel. Yes. All right, the answer to this question, guys, is atmospheric refraction, guys. The syllabus, the topic's name itself is what they're asking. That is what is called as atmospheric refraction. That is nothing but refraction of light because of the Earth's atmosphere. That is what is called as atmospheric refraction. Next one, atmospheric refraction explains the natural phenomena like twinkling of stars, sky appearing blue, refraction of light through a prism, or rainbow formation. What is the reason, or which of these natural phenomena is explained by atmospheric refraction? I'll start the quiz in 10 seconds, or sorry, I'll tell the answer in 10 seconds. I'm so used to saying in live sessions, so yes. I'll tell the answer in 5, 4, 3, 2, 1. It's twinkling of stars, guys. It's twinkling of stars because sky appearing blue is because of something called a scattering of light. Refraction through prism is called, that is through the refraction of light through a prism. That would be basically dispersion. And rainbow formation is again, it's a combination of dispersion, scattering of dispersion, refraction, and total internal reflection or internal reflection, however you want to call it. And yes, people, that is the end of today's session. Let me know what is the answer for this question in the comment section. The question is very simple. Why is it that stars twinkle and planets don't? Right, guys? Let me know what is the answer in the comment section. That's all for today. Do not forget to like, share, subscribe to the channel. Like I told you before, 5 years of bad luck is what follows you if you don't do it. Or was it 10 years? Whatever years it is, make sure you subscribe to the channel. All right, thanks a lot for joining. I wish you guys all the very best for your future, all the very best for your exams. I hope you guys are well on your way for your preparations and you are preparing sincerely for your board exams. All the very best, guys. I hope to see you guys in the live sessions pretty soon. Thanks a lot for joining. Catch you guys soon. Take care of yourselves. Have a great Sunday. Bye bye. See you all, guys. Take care. Enjoy.